Let's discuss the last section of this part 3, 55, the protected resource vulnerabilities, that is token replay. So let's quickly jump. So in the previous token section, we saw how it is possible to steal an access token even if the protected resource runs over HTTPS. Once the attacker gets their hands on the access token, they will be able to access the protected resource. For this reason, it is important to have an access token that has relatively short lifetime to minimize the risk of token replay. So we are already putting that, right? In general, in industry, the token lifetime is less for the access token. Indeed, even if an attacker manages to get hold of a victim access token, it has already expired. If it has already expired, the severity of the attack decreases. Correct, that is true. One of the main differences of OAuth and its predecessor is the fact that the core framework is free of cryptography. Instead, it relies completely on the presence of TLS across the various connections. For this reason, it is considered best practice to enforce the usage of TLS as much as possible throughout an OAuth ecosystem. Yeah, we need to introduce as much as possible the transport layer security in the OAuth ecosystem, like when we are transferring some message, communicating some message, right, from one party to another. Again, another standard comes to the rescue is HTTP strict transport security defined in the RFC 6797. So HSTS allows web server to declare that browsers should interact with only using secure HTTPS connections, never via the insecure HTTP protocol. Integrating HSTS in our endpoint is straightforward and, like CORS, requires adding a couple of extra headers. So add the appropriate header in a protected resource JavaScript file. So as you can see here, right? So we have already added the content type, X content type, and the XSS protection in the previous section, and then we have now the new header that is strict transport security and max age is equal to something. Let's go to the next slide. So in this case, like right, so this is here is the code, and then when we are trying to hit the /hello endpoint from an HTTP client, curl space -v -h with the passing authorization as a bearer token, and then we have the API with the language EN, you can notice the HSTS response header. So if you can see the output, 200 OK exported by Express, and then you have the access control allow origin, and then X content type options, access protection, and then you have the strict transport security, max is whatever, right? This header is added, and here is your result in the JSON form, that is greeting hello world. So at this point, every time you try to hit the endpoint with the browser using the HTTP, not over TLS. So you would notice an internal 307 redirect made from the browser, right? This will avoid any unexpected unencrypted communication. Our test environment does not use TLS at all. So this header effectively makes our resource completely inaccessible. Although this is very secure, it is not particularly useful as a resource. A production system with a real API will need to balance both security and accessibility. Definitely, it's not only we can think about the security only. We just need to think about accessibility also, how the APIs are accessible. So we need to balance those parts. So as a summary for the FF55, we can say sanitize all untrusted data in the protected resource response. That is one thing. We need to sanitize, right? Choose the appropriate content type for the specific endpoint. So content type you see, right, when you're calling the API, like application, JSON, text, whatever. So you need to put the content type appropriate for the specific endpoint, right? And we see that by putting application JSON, like that is one of the, again, the mitigation of the vulnerability. Rather putting content type as a text HTML. Leverage browser protection and the security header as much as you can. Use CORS if your protected resources endpoint needs to support the implicit grant flow, because we know in the implicit what is that disadvantage, right? There is a single call and no back channel communication, and you can get the token in the redirect format only. In the HTTP redirect only you will get the access token, and we know what is the problem in there. What is the issue, like how the attacker can craft a URL by impersonating an authenticated user and get an advantage. So we need to use the CORS if the protected resource endpoint needs to support the implicit grant flow. But we need to avoid this implicit anymore. We are not supposed to use this implicit grant anymore in the applications. We can go for PKC. Avoid having your protected resource support JSONP. Always use TLS in combination with HSTS. Right. So now we have discussed on securing the client and the protected resource. So now what else is left? So let's take a look. There are two things left, right? So we'll just take a look at what it takes to secure the most complex component of the OAuth ecosystem, that is the authorization server. So we'll talk in this two sections we talked mainly on the client side, we talked on the protected resource side. Now the third section we'll talk about on the authorization server side, and on the fourth section we'll talk about on the token side. So if in all this, like by covering all these four major sections, we'll end this vulnerability section, and then we can jump to other implementations sections of the Ping Federate. Okay, so this is just a general. This is not about Ping Federate, right? This is general content. Like for any of the product, if you are designing a solution or if you're using in any of the product, these things, you need to ensure that you are keeping this so that you can just make the system free from the vulnerability. Okay, so if you have any question, please put in the comment section, and let's meet on the next section with the OAuth ecosystem, authorization server vulnerability. Thank you.